It's time for us to build on the knowledge of analytical geometry that we gained last year. So analytical geometry is that beautiful space where geometry meets the Cartesian plane. And there are a couple of formulas that we need to know, and oftentimes they are given to you, either on the formula sheet or part of your question paper. So check with your teacher, but have a look at some of the formulas that we can expect to see. So the first one here is the distance formula. Okay, in other words, the length of a line segment. And what you do is you take the x-coordinate of the one point minus the x-coordinate of the other point, square it, and you do the same thing with the y-coordinates, and you square them. This distance formula is actually based on Pythagoras' theorem. Okay, and that can give you the distance between 2 points, and then pay attention to units if ever you work that out. The next one that we're looking at here, M, the pointy M, I like to call it, is for the midpoint of a line. Okay, and if ever you're asked to work out the midpoint, you literally add the x-coordinates of the 2 points on either side. So x1 from the one point, x2 from the other point, divide by 2, y1 from the one point, y2 from the other point, divide that by 2. That's a nice simple one. Okay, next up, curly M. Curly M is for gradients. Okay, M, gradient. When you write this down, be sure to use the right M's for the right thing. Okay, so your teacher knows what you're talking about. Pointy M, curly M. Okay, or capital and lowercase. This is a formula we've seen since grade 9 when we were introduced to the straight line. So by now we are quite good at it. y2 minus y1 over x2 minus x1. Just remember to put the y's on top and make sure that you don't confuse the different points. Okay, this formula over here is also a gradient formula. M is equal to tan theta. And that's grade 11 work. So we're going to look at that specifically in our next video. But just so you know, that's also a gradient formula that often comes on your formula sheet. And then these last two are simply the equation of a straight line. Okay, so this equation of a straight line comes up often in analytical geometry questions, and it's good for us to know how to work it out. Okay, this is the most common form, y equals mx plus c. By now, I hope straight away, jumping into your brain, you see the gradient and you see the y-intercept there represented by the equation. But there is this other equation. If you have the gradient and you're given one other point, you can substitute, so that's a plain old y, and then you substitute in the y-coordinate from the point you've got, and then you substitute in your gradient, you leave x, this x, and you substitute in the x-coordinate of your point. And then if you put it in the standard form, you'll also end up with a y equals mx plus c. So it's entirely up to you which formula you use there. Okay, let's put these into practice. In the diagram below, AB is a straight line. Calculate the length of AB. So for these ones, I just want you to pay attention. Sometimes they'll say leave your answer in third form. If they don't, then you're okay, and you can just give 2 decimal places, or whatever the cover of your test or exam says. Okay, so we're going to go with the distance formula. We are working out a length here, AB, and we're going to say x2 minus x1, and we square it, plus y2 minus y1, and we square it, and there we go. Okay, what is helpful for a lot of students is to actually assign and say, I'm going to call this point 2, and this here, point 1. And then generally, we make fewer mistakes when we substitute in. Okay, so what we need to do is we need to substitute. So x2 is 5 minus, be careful here of the double minus, minus 4. And that's going to be squared. Plus y2 is 2 minus, again, a negative, minus 3. And that needs to be squared. And all of that is in a square root. Okay, now you can work this out step by step, but you've got a calculator, so you may as well jump straight in and type that into your calculator. Okay, so that gives us the square root of 106. And because it didn't specifically say third form, we are going to put that into decimals. 10, 3. You can write 30 if you want to. But that's it, rounded off to 2 decimal places. Okay, next up, they want us to calculate the gradient. Okay, gradient is curly m, y2 minus y1 over x2 minus x1, and we're just going to sub in. Okay, another notation here is you can say the change in y over the change in x. This is actually the Greek letter delta, and it means change. Okay, y2, we've already labeled our points, so 2 minus 3. I like to just do that double minus and straight into a plus, over 5 minus 4. Okay, so that gives us 5 over 9, and that is going to be the gradient in its simplest form. Next up, they want us to calculate the midpoint of AB. Okay, so that was the gradient of AB. Now midpoint of AB, and that's where we take our coordinates, so x1 plus x2 over 2, y1 plus y2 over 2, and we are going to substitute in to get a point here in the middle somewhere. Alright, let's substitute. So minus 4 plus 5 over 2 and minus 3 plus 2 over 2. We end up with a half. You're welcome to type this in on your calculator, and minus a half. So here is our midpoint at a half and minus a half. Okay, often these diagrams are not drawn to scale, so don't panic too much if it doesn't look 100% accurate. And then finally what they want is for us to determine the equation of this line AB. Alright, we've got two formula options. We can choose either one of them. Let's go with the one that we know very well. So y equals mx plus c. We already know what the m value is. That's this over here, this 5 over 9. So we can substitute that in. Y is equal to 5 over 9 x plus c. Then we can substitute in another point. So instead of y, let's put a 2. I'm choosing point 2 there because it's got no negatives, which does make my life a bit easier. 5 over 9 times 5 plus c, and then we can work out what c is. So it becomes 2 minus 25 over 9. Let's get the calculator out for that. 2 minus 25 over 9 gives us minus 7 over 9. And so therefore, y is equal to 5 over 9x minus 7 over 9. Okay, and so if they were to ask me what is the y-intercept of this line AB, I could tell them it's minus 7 over 9. Now before we move on to our next example, let's just take a moment to recap what we know about parallel lines. Those are two lines that are flowing in the same direction. They'll never touch each other, and their gradients are equal gradients. Okay, they love to ask this. And then we've got perpendicular lines, which are two lines that definitely intersect, and in fact they intersect at a very specific angle, and that is a 90-degree angle. And their gradients are not equal. We can multiply them, and the answer should be minus 1. And so what's an easy way to remember is that these two, the gradients are the negative reciprocal of each other. Okay, and so what that means is that the gradient of the first line, let's have a look at a little example here. If the gradient is 1 over 2, you can multiply that. The reciprocal in fraction is just the upside down. The numerator becomes the denominator becomes the numerator. Okay, so you can multiply it by that and the negative, and you'll see that that will give you an answer of minus 1, because 1 times minus 2 gives us a minus 2. And then in the denominator, 2 times 1 gives us 2, so it's minus 2 over 2, which does simplify to minus 1. Okay, so important to note, parallel lines, equal gradients. Perpendicular lines, we can multiply their gradients to give an answer of minus 1. Here we have one more example. In the diagram below, triangle PQR is a right angle triangle, and PR is produced to point S. Okay, now that might seem like silly information to you, but it's very important because if they tell us it's produced, what they mean is that we're dealing with a straight line. Okay, and so that would help if we needed to know, how much is that angle, because angles on a straight line add up to 180 degrees. Let's look at these questions. Calculate the length of PR. Okay, by now we are good at this. So question 1, PR is equal to, we're going to use that Pythagoras-inspired formula. So x2 minus x1 squared plus y2 minus y1 squared, all under a root. Okay, helpful if we label our points. So x1, y1, x2, y2. Let's go for it. x2 minus x1 squared plus y2 minus y1 squared. And let's see what we get. We get the root of 26 there, okay, which they didn't specify they wanted insert form. So we are going to put that in decimal place, and we get an answer of 5,10. Okay, the length of that little line segment. Now they want the gradient of PR. Okay, so question 2, gradient of PR is equal to, and we can use our gradient formula, y2 minus y1 over x2 minus x1, and we can calculate that. So y2 minus 2 minus 3 over 1 minus 2, and that gives us a gradient of 5. Now next up they want us to determine the value of A. So if you look closely, A is this x-coordinate of the Q, the point Q over there. Alright, and so what we need to do is figure out how exactly we would do that. And something we haven't used yet is the fact that these lines are perpendicular. And what do we know about straight lines that are perpendicular to each other? We know that if we multiply their gradients, the answer should be minus 1. Okay, so what I can do then is over here perhaps, let's work out what the gradient would be of PQ. So gradient of PQ with my curly bracket there. I am going to say y2 minus y1 over x2 minus x1, and let's do that. Minus 2 minus minus 1 over 1 minus a. Okay, so there's my gradient. In fact, the numerator there has some like terms, so we can call that minus 1 over 1 minus a is the gradient. And so now, to answer question 3 here, what I can do is use the fact that if I multiply these two gradients, I need to get an answer of minus 1. So we've got minus 1 over 1 minus a is multiplied by 5. I'm going to make that 5 over 1, just because that does make my life a bit easier when I have to multiply all fractions. And it needs to equal minus 1. Okay, so what do we have? We've got minus 5 over 1 minus a is equal to minus 1 over 1. We can cross multiply that. So we're going to take the denominator here times the numerator there, and the opposite over there. That is then going to become minus 1 plus a is equal to minus 5 if you multiply that out. And so a is equal to minus 6. Okay, and if we have a look at the sketch, that does seem possible that it could have an x value of minus 6 there. Just important to note the process of doing it. So they asked us to determine the value of a. It was a missing coordinate. Because I had just worked out a gradient here, it was a big clue for me. But I would generally look and say, do I have a distance? Do I have a something? And so I had the gradient. I knew that if I could work out the gradient here of PQ, I could then multiply those two gradients together. And so that's how we got that. Okay, let's go to a new slide there to tackle question 4. It says there, if R is the midpoint of PS, determine the coordinates of S. In other words, we want to know what's happening here. Okay, well, midpoint is not too bad, especially when we're working it out, but since they've given it to us, we are going to apply a very similar approach, and we're going to say, well, according to my midpoint formula, let's quickly color code. So all the x coordinates are going to go together, and all the y coordinates are going to go together. Okay, according to our midpoint formula, if we were to add x plus 1 and divide by 2, we need to get that answer in the middle there, which is 2. Okay, and then it's just about solving the equation. So let's do that. Multiply the numerator on one side with the denominator on the other, and then vice versa. And then we end up with x is equal to 3. Okay, and then finally for y, we'll say a very similar approach. Y plus minus 2 over 2 must give us a coordinate of 3. Okay, I'm going to again pop that over 1, and then I'm going to do my cross multiplying thing. The other thing that I'm going to do to make my life easier is this plus minus. I'm going to quickly say that's a minus over there. So then we'll have y minus 2 times 1, and then equals 2 times 3, which is 6. We're going to take that minus 2 over, and y is equal to 8. So there we have it. It's about looking at what you've got and applying it to one of those formulas that you've been given.